All righty. Well, we're definitely at time. So why don't we go ahead and get started? This is going to be the Spot the Bug session. First thing I want to do is say a great big thank you to the sponsors. This is a very challenging year, and it's hard to get a conference like this together when it can be in person, let alone when it's virtual. You've got a lot different needs and things that need to happen there. And these folks have made this happen. So if you get a chance, please visit with the sponsors for us. They've done a wonderful thing by enabling us to be able to be here today. All right, so who am I? My name is Darren Hale. I create software. I've been creating software for well over 20 years. Most of it has been object-oriented. I started my career doing Visual Basic. This was before .NET existed. I then moved into doing Java, and I did Java for a number of years. I've been doing C# and .NET for about the last 15. So that's been my focus for a good while. I'm fairly easy to get a hold of online. I've got all my contact information up there. I will try to remember to pop this back up when we're done at the end if anybody needs to get a hold of me. Okay, so what are we going to do today? We're going to look at some code with maybe some not so obvious bugs. This whole thing started for me several months ago when I was going through some code that one of my teammates had written. And this teammate, I wouldn't say is a junior programmer, but is on the beginning side of the career versus where I'm at, right? I'm smack dab in the middle of my career. This person was certainly more on the beginning side. And the code that he was working with was a little bit complex in that he was dealing with an external system, sending us files and data, trying to process those files and get all that stuff into the database in a good way. There was a minor bug in the code that hadn't shown up yet. I noticed it because it was a pattern that I learned early on, because when I did it, I created a bug and things didn't work. But a lot of that stuff that I learned early on, it occurred to me, disappeared as our languages have evolved. And it's made it easier for developers to not write buggy code, but it's also made it easier for developers to not necessarily understand the design concept behind those constructs. So that's where this session was born from. It was originally intended to be highly interactive, highly fun. It was really kind of a just and spot the bug. So it was meant to be an interactive dialogue. So it will be a little interesting to see how this works here. I do have split screens. I've got my presentation in front, so I'm looking at all of you as I present. I've got the chat on the side. If you have questions, please throw them out there on the stuff that we're going through. I'll do my best to glance over from time to time, but if I get kind of ramped up and going, I'll come back and address the questions later. Because this is a highly interactive approach, really to talk about design, I'm hoping we can fill the full hour. There's a possibility that without the in-person interaction, it may go a little bit faster, but we'll see what we can do. Another thing that I think we should keep in mind is that this presentation really has two different facets to it. One facet is geared a little more towards those that are a little more junior or early in their career. The other facet is those that are much more in the latter part of their career, where they're in more of an architect or mentoring type of role. So for the folks early in their career, what I'm hoping to do here is to introduce some very common mistakes that you're most likely aware of and talk through some ways to mitigate those. I don't necessarily display the way to mitigate those in this particular presentation. It's part of what I'm trying to kind of figure out as I do this so that I can present this in a good way. The idea with the junior folks there is that as we introduce these, they give you a topic to dig in on further or to explore further. For the folks that are more in an architect or a leadership role, what I'm hoping to do here is introduce ways to highlight some of these things, ways to bring these issues into the awareness of those that you're mentoring, and to find a fun way to talk about design concepts and to help grow people forward. A lot of the complaints that I've had in my role as an architect and a leader throughout the years is that new people into the field don't know what their career path is. They don't know how to grow from, I'm new, I just like writing code, I want to write all the code I can, to how do I architect and design systems. A lot of that is learning how to communicate. So some of this is just how to have fun communicating and talking about things that might not be quite right. A lot of that is trying to find ways to challenge ourselves and to ask our code questions. So we'll talk about that a little bit as we go through. I'm not going to hit on that too much, but I'm more than happy to talk about that, sometime afterwards, or you can hit me up online, and that could be a very fun, spirited debate. Okay, so with all of that laid out, one other minor programming note, just so you understand what you're seeing. I'm using Emacs as my text editor to display my code today instead of Visual Studio or VS Code. Because there's a good bit of code on there, I didn't want a lot of the Chrome and the widgets and things of those editors out there causing problems to see the code. I really just want to focus on the code and make that kind of the highlight of the conversation. That is the only reason I picked what I did. Most of these code samples are capable of being compiled and run. I have done that through pretty much all of them. There may have been a tweak or two as I was finalizing the presentation that I haven't checked yet, but they should be fairly easy to get running if you need to run them. I'm still debating how I publish these out at the end, but if there's something that you want to get a hold of or some code that you want to run and play with, reach out to me either through the conference or online, and I can get that out to you. Okay. So let's go ahead and get started with our code. All right. Hopefully everybody can see that. We'll try to hide this back here so we don't see that going forward. Okay. Is that visible for everybody? And everybody can read that? Okay, perfect. So the first one we're going to talk about is fairly easy. I've got a class here called Data Gatherer. It's got a connection, a database connection as a property. It has a method that opens that database given a connection string. So it does the normal string checks, safety checks around the connection string. If it's a good string, it tries to open the SQL connection. It creates the SQL connection object, opens the connection, returns the result of true. If that fails in there, it's going to return false. I then have another method called close the database, and it's going to take that connection, close it, and return true. And then I have a method that works with the data. So he's going to open the database, he's going to do some work with it, and he's going to close the database. Where's the bug? And keep in mind when I say, spot the bug or where's the bug, it's not necessarily something that won't compile or something that won't run, but it could be something that's going to hurt us further down the line. This is where I give everybody a chance to answer and converse out loud. Does anybody see it? A lot of people are probably looking at this going, why are you doing it that way? Why aren't you just using the using construct to work with your database connection? Well, that has to do with what the bug is, right? In this case, work with data calls a separate method to open the database and a separate method to close the database. It becomes almost trivially easy to forget that closed database call. At first, that might not be a huge problem. Garbage collection will come up and clean that object up later. So if you've got a small application, it's a little bitty one, a kata style application, this may not show up for you. However, if this is running in a server environment, in a server context where it's being hit hundreds or thousands of times a day, leaving that database connection open is going to use up resources on the database. It's going to use up networking resources between the server running this code and the database. It's also going to burn up memory on the machine that's running this code. But when we do this, it is really, really easy to skip this operation. It takes a lot of mental energy and mental thought for a developer to do this the right way. So if we move to the solution, oops, moved. There we go. There we go. Okay. All right, my little screen share thing down here is causing me problems to not be able to see my editor. So we're going to scroll that up just a little bit if we can. Whoop, there we go. Perfect. Okay, so this would be the better way to do it. And my formatting got off. Right, is to use the using construct. C# gives us this really nifty tool to control this. And what this is doing is it's ensuring that the code that opens the database is the code that closes the database, right? That should be going too. Like I said, I was doing a little last minute tweaking. This construct is forcing the developer to use a design principle that says one thing should be responsible for opening and closing the database, right? In my last example, I could argue that my class was the one thing that was responsible for opening and closing the database, but I spread that responsibility out over two different methods, and I left it up to the user of that class, the developer, to do the right sequence of events. In C#, they use the using construct to force that, right? So in this case, when I create the new connect SQL connection, I do still have to open and close it. But when I fall through that block, the using construct will call the dispose on the SQL connection. It may still cause some problems with the connection to the database itself. It may leave some resources hanging on the database side, but from our side, it will mark that object as disposed, allow the garbage collector to clean it up, and behave better than if I'm doing that on my own. So the design principle here that really gets masked is that when we're dealing with things like databases, there should be one thing responsible for opening and closing that database. If I need to separate out that little area that says do something with the data, that can be broken out into something different. But what I should do there is pull that data into a different storage mechanism, a different data structure, pass that data structure to my other objects that will work on that data, but close the database before I move on, right? That way I'm not holding those resources open. The using construct helps force me as a developer to think about that because I have to keep it all in one block, right? If I start writing using statements that are calling out to multiple classes and multiple blocks, this thing starts to get really, really big. It gets really hard to test, and it starts to signal to me as a developer very quickly that I'm not doing something quite right. No, I wasn't doing that. Again, these are trivial examples. The comment is I'm not checking the value of the open database. I'm skipping over some of that stuff just to highlight the design principles, right? This is really a conversation around design. The examples are not perfect by any means, but they should be illustrative of code that we see out in the wild. And in this case, with the using construct around the database, this is the accepted way to work with a database connection. This should exist in almost everybody's code at this point. The code before is a trap that's easy to fall into if we're separating these concerns out. I'm highlighting this on a database connection because it's easy for everybody to see, understand, and reason about. But this could be true of many other things. If we aren't keeping responsibilities together and owning the right responsibilities, it causes issues if we get into multi-threaded applications, when we get into maintenance and upkeep of the system. That separation just gets hard to reason about and allows us or even pushes us to make more bad decisions as we go. Okay, let's move on to the next one. Oops. There we go. Okay, next one up, I've got another class called Data Writer. He does an open file on a file name as a string and returns a stream writer. I have a write data method that takes a stream writer and my data as a list of strings, iterates through that list and writes them out one at a time, returns true when he succeeds. I then have a close file method. Down below, I've got my program, my main method that news up the data writer, opens it, creates my data list that I'm going to write out, and then calls write data. Where's the bug? It's very similar to the last one, right? In this case, I'm not calling the close file method that I defined in my data writer class up above. At this point, I'm leaving file handles open. I'm eating up resources on the computer. I will probably find this problem a little bit faster than I would the database one because of it's hurting the box that I'm running on and not necessarily a different box, but it's the same type of problem, right? So if we move to the solution to this one, of course, my formatting decides to not cooperate for me today. We see that the using construct is the thing that keeps us good and honest on this one, right? The entire design of splitting up those file operations is not what we want. We want to keep those bundled together so that we read and write that in the same block of code ideally, so that we can control the opening and closing. It's a lot easier to reason about. It's a lot easier to ensure that we're doing the right things by closing the database, disposing of the stream writer as it comes through, and ultimately it reduces the amount of code that we have to write and maintain. That's not to say that there aren't times that we do need to create abstractions over things like StreamWriter or the system.io namespace, but when we do, those are more complex operations and they should be handled with care. This is another illustration of that using construct, forcing me as a developer to think about keeping like responsibilities together so that I do the right things. They can't ensure that I call the close method on the data writer, but they can certainly ensure that the dispose method gets called on the stream writer, which is what happens under the covers when you fall out of that using block. And that will start to clean things up. They can use compiler magic under the covers to do the right things with the resources as we go. This is one area where the language is evolving in a way to help us do the right things. Okay, how we doing? We good so far? All right, so most of my code samples as a programming note are C#. The next one is the only one that isn't, and I will explain why. It's actually going to be PowerShell. And I want to, there we go. Everybody see me again? Yay. Technology is wonderful. Sorry about that, everyone. All right, everybody see the screen? Fantastic. Okay. I don't know, where did I drop off? I was just introducing PowerShell because I think I saw somebody with concerns that I'm going to start showing a little PowerShell. Okay, so the reason this next one is in PowerShell is twofold. One, I can't actually illustrate this bug in C#. The C# libraries for dealing with files don't allow me to do that, and it'll make sense in a minute. The second is that there's a prevalent notion that PowerShell and automation is not code and that it can be dealt with differently. And that is absolutely not true. So I want to bring this up because bugs exist in PowerShell, and when they exist, they can have really detrimental side effects. So without further ado, we bring up our PowerShell. So I've got a very basic little script. Keep in mind that when this was presented to me, the script that I was looking at was much, much larger. There was a lot more going on. But I get a file list using get child item from FileDir. I then iterate through that file list, and for each file, I copy it to an archive directory, and I copy it to a pending directory. Once I've iterated through that, I remove all the items in my FileDir directory. Does anybody see the bug? I'm going to give you a minute because it is PowerShell, so we got to switch our mindset just a little bit. Yep, awkward silence. This is where the interaction would be really, really handy. So this one's really hard to spot, especially if you're either not familiar with PowerShell or this is in a bigger script. So when I'm going through that file list, if the time to iterate through that file list is significant, and in the case of the automation script that was doing this operation, the time was significant. We were dealing with multiple 100 meg files, so those copy operations were taking minutes, sometimes up to 20 minutes, depending on how many files we had queued up at a time. Over the course of that time, new files were arriving in that FileDir directory. Once I got through iterating the first snapshot of the contents of that directory, my remove item is using a wildcard. So I'm deleting everything in that directory, regardless of what I pulled out and archived. So this code was actually destroying new data that we weren't accounting for or doing the right things with, and they were just disappearing into the ether, right? So that's not good at all. Oops. I apologize. My keyboard does not want to play nicely today. So the right way to do this is here. What I want to do, and I stress this in automation, and it's really baked into the language in C#, is that I want to, what I would always term, positively affect anything that I'm working on. So in this case, if I'm getting a list of files from FileDir, when I iterate through that and I do my copies, I want to remove my item by specific file name and not by wildcard. Because if I do that by the wildcard, I could destroy data that I was not aware of before. I need to be aware that I'm taking a snapshot in time. And it's really easy to think about file operations are a snap. When you start dealing with larger files or bigger files or networks, they may be a snap, but there's going to be some latency there. And if I'm not careful, I could destroy newly arriving data because I'm not aware of it. So whenever I'm working with things like files in a file system, I need to make sure that I am touching each file by name and not by wildcard. I may take my snapshot and my point in time view by wildcard, but then after that, everything has to be on a per named file. And I have to be able to account for each named file all the way to the very end, right? Where that wildcard existed in that buggy code, I could not tell you what happened to any given file on that remove because I wasn't calling something on an individual file. I couldn't log it, I couldn't track it, I couldn't do anything with it because of that globbing operation. I bring that one up because the C# language constructs in the system.io package don't allow you to delete by wildcard. You have to give it a file name. That ensures that you're doing the right things and you're not doing the kind of harm that you could do in PowerShell. Now, if you're writing PowerShell, you can use the system.io packages. You can open up any .NET package. But when you're writing PowerShell, the canonical examples are exactly like what I'm showing here. So I know a lot of you may or may not be doing PowerShell, but certainly as you move up in a more senior leadership role as an architect role, if you're dealing with automation, these are some of the things to watch out for. This one is especially nasty because even if I had put unit testing around this PowerShell snippet, I may not have found this problem because an external operation was moving files into the starting directory. So unless I was simulating the entire system at scale in real life, I was never going to find it. And if I didn't have tests to ensure that every file that came in was adequately handled on the output side, I would have missed this. So this one was really, really nasty because it would be hard to guard against even with unit tests or even integration tests for that matter. Okay, back into the C# world. Okay, for loops. So here for this example, I have a class called matrix adder. It has a static method that's going to take in two 2x2 matrices and add them together. I then have a print matrix method just to make sure that I could see what's going on. And I apologize for the messed up padding and spacing. I don't know what happened there. Oops. Actually, I do know what happened there. It's demo time. Okay, that should be a little easier to read. Down below, I have a program main. I declare two matrices. I add them together. I print them out because I really needed to do that to see the bug that was going on here. This code absolutely runs. It works when we fix the bug. And I want to give you a minute to see if you can see where the bug exists. This one's a little bit nasty too. Unfortunately, the language doesn't help us with this one as often. So I'm generally a fan of using I and J for iterative loops because those are generally just indexes and counters. They don't necessarily have a lot of meaning. In this case, though, because I and J look an awful lot alike and I've got nested for loops, right here, I interposed my indices. Yep, my I and J is backwards in my addition result. That's exactly what the bug is. This one feels fairly basic. A lot of you are looking at this going, well, yeah, that's exactly what that is. You got to flip them and you're good. The reason I point this out is that I remember as a very early dev making this mistake far more often than I wanted to, especially in school. This one is hard to avoid because it's hard to see that immediately. Depending on your eyesight and the fonts you're using in your editor, the I and J can look an awful lot alike. somebody commented that that's why they only use X and Y. I guess I will sometimes use X and Y. I've got a little bit too much of a math background in me that in algebraic notation, X and Y's and Z's were always meant to represent things that you didn't know. Whereas like A, B, C, like the first half of the alphabet was always well-known values. And for some reason that comes out in my code. Now, if we look at the way I solved this in the next example, I got stupid nuts with my variable names. I made them almost too large, right? It makes it really hard to even see the loops all on one screen, especially with my formatting being off. But by naming them very, very blatantly, first index, second index, or first matrix index, it makes it a lot harder for me to flip. It makes it much easier for me to see and reason about. You know, at a normal Zoom level, this does fit on one screen, and it's easy to kind of see. Honestly, the right approach here is not necessarily the INJ. I would never fault a junior dev for using INJ in those for loops or X and Y or whatever those variables are. I do think that this is a case where unit testing will absolutely save your bacon, because the addition of two matrices is a well understood problem. It's something of a pure function in that given two inputs, you will always get the same two outputs, especially the way I have it written here. I can write some easy unit tests around this, or straightforward unit tests, to ensure that this works exactly the way I want it to. And in some degree, what I did when I created this example, the main loop and that print mechanism, I was visually inspecting it to make sure I got it right the first time and that I put the bug in the right way and I got the right result. Had I been doing this with test-driven development and unit tests, I absolutely would have had the right safety net around this. And if those are running as part of my continuous integration, when somebody comes along and accidentally swaps those indices, the tests blow up. It may be a little harder to see without good naming conventions around those variables, but at least I will catch that. This one I point out not because the language does something to help us or because it's a major design issue, but it's certainly an issue that comes up with new developers. It's certainly an issue that anybody in a mentoring role will have to encounter with a new developer. And these are some ways that you can either talk through it, work through it, or reason about what's going on with that. I like that about the variable names being Mexican food names. The only thing I don't like about it is that if taco represents a financial sum, it's hard to read and reason about that. And I'm a very big proponent of my code reading as much like prose as possible to convey meaning, at least when you can do that. Okay, next bug up, strings. And this one is honestly a little less about a bug. This one gets a little more towards what an architect or a senior dev or a tech lead may need to deal with. Here, I've got a class order confirmer, and it's got a method that sends a confirmation. It takes the order in, it generates a mail message, it sets up the from, the subject, the message, and then it actually sends that out with another message within itself for maybe logging purposes. This one is really not so much a bug, especially if you get 1 to say 10 orders a day. If you're getting 10 orders a minute, 1,000 orders a day, this gets a little bit trickier. It's not so much a bug. The code works, it will always work. You may find yourself as this ramps up in scale and you go from 1 or 10 orders a day to 1 or 10 orders a minute, that you're throwing more memory and hardware at this one little order confirmer. And that's a little bit crazy. All of a sudden, you're architecting new microservices so that you can isolate this thing and let it chunk away slowly and not break other parts of your system. And the reason being is that we're doing a lot of nasty things with strings. As we know in C#, strings are immutable. Once you create one, it lives on the heap and doesn't go anywhere. It just generates new strings. So for instance, my from property on my confirmation mail, where I'm taking string customer support at plus company domain, I'm actually dealing with 3 different strings right there. The customer support at is one, company domain, which was declared before, is a second, and then the concatenation of the 2 is a third. So I've got strings all over this code that are eating up memory on my heap and causing the resources to diminish, right? So if I'm dealing with 10 orders a minute, I'm going to quickly max out what any server running this code can do. The right way to handle this, and it's going to be a little hard to see, is constants. Exactly right, Floyd. If you create these as constants, the compiler will bake these in and create these as compiled spots in memory. I'm then also using a string builder to concatenate my message together so that I minimize the number of strings I'm creating at one time, right? The append mechanism goes in, puts that into its data structure. I don't get that new big string out until I call message.toString from my string builder. This looks very similar, and a junior dev is going to look at this and go, it looks exactly the same. It's not doing anything different. The things to point out with this are that the const keyword, declaring those strings as constants, allows the compiler to build them once into memory and then refer to them in the future. When I'm declaring them as variables, they get declared as new variables and thrown on the heap, right? And those don't get cleaned up until they go out of scope. You've got to let the garbage collector do it. And the more stuff that's there, the longer the garbage collector runs, all those problems then ensue. By doing this here, I'm creating them and plopping them in a different area in memory. The garbage collector will probably not come around and deal with these because they're declared as constants. They're just going to float out there, but I've got a one-time hit on my resources and it doesn't go up and down all the time. My string builder is much the same way. It is a construct in C# that builds these strings into a data structure so I can build a larger body of text. And then I only have to pay the penalty of generating that string once when I call the toString method. A few other things to note that I could possibly do with this as I go forward is that this class could be static because it's not holding state in any way, shape, or form. The send confirmation method could be static. Those kinds of things will also go a little ways down, pre-compiling some of this stuff and making them more efficient to run on your system. Good, I'm not fooling anybody. That's excellent. All right, next one up is this guy. So I've got a class called interest-bearing account. He has a constructor. He takes in two properties. He populates two of the properties, the opening balance and the interest rate. He's got a method called calculate interest. He calculates the interest earned and sets it on the internal property and returns that back out. I then have this accountant class. He has a method called determine interest earned. He takes in an account balance and a rate. He then checks to make sure that they are greater than 0. If they are, he creates a new interest-bearing account object, calls calculate interest, and returns that back out. Down below, just so you can see there's nothing weird hanging around underneath there, I just have a basic main method that creates the new accountant, calls the determine interest earned on args passed in. I should do some checks around values on the arg thing, absolutely. And then I'm logging out the interest income. Where's the bug? And I apologize that the formatting got off a little bit. My Zoom screwed that up a bit this morning. So where's the bug? Again, this one's a little bit harder to see, especially depending on where you're at in your career and your understanding of object-oriented technology. So all of this works. There really isn't a problem. This will always function. Your unit tests pass if you've written unit tests around this stuff. The difficulty I have with this is this line right here, right? That guy right there where I'm newing up the interest-bearing account within the accountant class is not good. And I say that for many reasons. First, from an object-oriented design principle, I am now tightly coupling my interest-bearing account class to my accountant class. At this point, if anything changes with the constructor of the interest-bearing account, the accountant class has to change as well. There's no separation there, right? These two things are going to be married for the rest of their life. Second, I've got no way to control the resources being used because the accountant class is generating new objects, right? If a new dev comes in here and they see this, as the accountant class grows, and they see this pattern in the code, they're most likely going to repeat that pattern again. So they're going to start newing up more objects as they need it, even creating an even tighter coupling with other classes, possibly some that have nothing to do with accounting principles at all whatsoever. And they're going to start generating more and more objects where maybe they don't need to do that, right? So this one gets a little bit to a performance side, but it's really more a design concept. Things like dependency injection is exactly what was conceived of to solve this problem. So if we go to the solution that I've got for this, it helps when I hit the right keys. So I've got my same interest-bearing account. That guy hasn't changed. I've got my accountant class. But the difference here is that instead of taking in a balance and an interest rate, he's taking in an interest-bearing account. He's leaving the responsibility of creating that thing up to somebody else. He has a dependency on effectively the interface, right? And if I was doing this really well, I would have coded the interfaces and not concrete classes. But again, I wanted to keep this simple so we could see most of the code on the screen. At this point, if something changes with the interest-bearing account, I only care about the calculate interest method. Most likely, that thing's not going to change. He's not taking in any parameters. He's got a decimal output. He's a fairly simple interface to worry about. My coupling has been reduced quite a bit. I leave the memory management of that to my calling routine. So my main method that we can see now on the screen, it generates the new interest-bearing account and can then pass that into my accountant class in that method. In this case, this is method injection. If you hear that term in the dependency injection world, we're injecting our dependency in at the method level. This is probably the least intrusive way to do it because I'm only injecting something in that I need at the point in time that I need it. You will also see constructor injection, and I did not highlight that here, but constructor injection means when I create the new accountant object, I will put my interest-bearing account object into him as I get started. That's the model that you'll see quite often with dependency injection frameworks, especially the one that's built into ASP.NET Core. I didn't get into the details on that. I could probably do an entire talk on dependency injection and the patterns that go along with that. But I wanted to start to highlight this because you see this crop up quite a bit. And I know most teams that I've worked on, the running standard of code was mimic the pattern of the code that you're in, right? Maintain the style of the code that you're in so that you're not mixing and matching styles. It is very easy for a junior person to come along, see the previous code where I'm newing up my object in another object and say, oh, that's the pattern that's here. I'm going to continue mimicking that pattern. And they don't necessarily feel empowered to raise their hand and go, I think this is a problem. Is it all right if I break this out and change the dependency on this? For a junior dev in a large company with architects and all that, they probably need to ask permission. In smaller companies, they may be empowered to make that change. If you're mentoring someone younger, I would highly recommend using that as a trigger to say, if you see this, ask for help or run in and make that change, right? If it's in certain areas, feel empowered to go make that change. That's how they can start to learn good object-oriented design and not proliferate bad patterns that then somebody else has to come back and clean up later. Okay, next one up. Okay, so on this one, I've got a class called order. He's got 3 properties. I made them public just to keep it easy to work with the object. Normally, I would make them private. I'd create public getters and setters. I have a calculate order amount. I have an isValid method. I have a submit, a cancel, and I apologize again for the tabbing on this. And then I've got a send order confirmation method. And that guy takes in an email address. He's going to generate an SMTP client, a new mail message. He's going to construct that mail message and send out that message. Down below, I just have my calling program. He creates a new order. He sets the properties. He checks if it's valid. If it's valid, he logs something out to the console. He then submits the order and sends the order confirmation. If it's not valid, he also logs out to the console and then cancels the order. Nothing fancy down below. Just generally speaking, here with the calling program, I'm including those so that the example is runnable and workable within an IDE so that people can play with it and work with it and manipulate it. But the bug is generally up above that calling routine. So what's the bug? In this case, all of the code works. And for the simplistic case, it's probably not terrible. But I would argue the send confirmation method doesn't belong on my order object. My order object has too many responsibilities at this point. If I were writing a unit test and test driving the creation of this order object, I would start to see the issues crop up as I have to start figuring out how to mock out or handle the SMTP client, the mail message object. How do I handle the client.send? Am I actually going to send an email message out? And I'm asking myself the question, what does this have to do with my order object? And the answer is nothing. It is easy in a trivial example like this to drop this the method for the confirmation on my order object. The problem though is that if I do that early, it's going to then start to force me to make choices later, especially if I've got somebody who is more green in their career and they've got to come in and modify the order object. And maybe the modification is that, hey, our order confirmation now needs to go either to an email or to text message. You need to take in a config value to figure out which one that's going to be. Now, all of a sudden, you're going to start to see a send order email confirmation method. You're going to see a send order text message confirmation. Then you're going to see a send order confirmation that does the switching logic on, is it an email or a text message, and then calling those two. All of a sudden, your order object is getting really, really big, doing things that it really shouldn't be doing. So the right way to handle that, obviously, is to create a confirmation manager class. I don't like the name, but it serves for this purpose, right? Because this guy isn't holding state, or he's going to have to manage the connection to an SMTP client, I want to create him as a separate class. I can treat him differently. Once I do that and I've separated those concerns, now when somebody has to come in and change the confirmation to be text or email, they're not dealing with the order at this point. They're now dealing with the confirmation manager, and they will start to make better decisions. Maybe they will do exactly what I described before, and they will create one method for send email confirmation, one for send text. Send order confirmation gets refactored to do the switching logic so that the downstream calling routines don't change. That's a decent approach. It may not be perfect, but it's the right next step. Then the next time they come in and they have to make another change to the order confirmation, now they're looking at it as a whole and it's not being muddled with the order. Even better, if they have to make a change to the order, choices about the order are not being influenced by that confirmation thing. So in the previous example, it was trivial and small, but let's say I've got to do something else with that order, right? I've got to, say, split the order to go to 2 different vendors. And I see that I've got the order proper, I've got my confirmation on there, I might as well just put the split on there as well. So now all of a sudden my order object is gaining more and more responsibilities, and this thing's getting glued into the rest of my code in weird ways to where my system is becoming this one great big knotted ball of twine. If I ever then have to break this system up into microservices or a distributed model for whatever reason, it's going to become really, really hard to do because everything is so tightly coupled. If I split these out early on, and this is really a message to the senior folks and the architects, if I make these splits early on, it gives me more power and flexibility for the broader architectural shifts and system shifts that may have to happen. It also forces the development teams to make better choices about those objects so that when it comes time to do those splits, it's still fairly easy to do. All right, we hanging in there? Keeping up with everybody? So far, so good. Okay, next one up. This one is actually the reverse of that problem. I've got my order object again. I've got calculate order amount. I've got a new class called order validator. He's got an isValid method. He takes an order in. He checks all the properties to make sure they are the way we need them to be. And if they are, the result is true and it returns true. If they aren't, it generates false and returns false. My program method down below is almost identical to the one before, except that I've got this new validator object that I've got to create, and then I'm calling validator.isValid. Where's the bug? And I kind of tipped my hand when I said this is the opposite of the previous problem. Yep, in this case, there are too few responsibilities on the order object. By splitting out that validator, I've tightly coupled the order validator and the order object, right? The order validator needs to know about all of the properties on the order so that if anything changes on that order object, the order validator is going to have to change as well. This pattern here is just as easy to do as the too many responsibilities as the too few responsibilities. I have seen this one maybe more than I've seen the too many responsibilities problem, on where people really start to get the hang of object-oriented development. And if they're doing test-driven development and they're coding to interfaces, they start creating abstractions. And this happens really in what I call that kind of sophomore time period of a developer, where they're no longer brand new. The ideas and concepts are really starting to gel in their minds, and they're starting to spread their wings and explore what they can do. And I think that exploration is great, but it generally generates code like this, where, hey, I've got this order validation. I can call that out into an iOrder validator. I'll create an implementer method. I can test it independently. It's going to be fantastic. But in reality, that separation, all that's done is created two separate classes that are intimately familiar with each other. The order doesn't so much know about the validator, but it is dependent on the validator being present for the rest of my business logic to succeed. And the order validator absolutely is dependent on the order object to even function to do its job. So the right way to handle that guy, is to keep the validation method on the order, right? The way you would see this in a test-driven development world is that when you're setting up your test for your order validator, when you are setting up the order object, or you're mocking that order object, and you're doing more work with the order object to test the validator than you are with the validator object, that's a hint to you as a developer that I've got something not right, right? And those hints that come up, and I'm a big fan of test-driven development because those tests will generally give me hints, but I have to be aware of the hints. In that case, I'm doing a lot of work with a class that's not under test to test the class that I want to test. At that point, if I'm a junior dev, I've got a question, right? I want to go to my mentor, the person that I'm working with, and say, hey, I'm building this out. I'm doing all this work. Something doesn't feel right. I want a second set of eyes. And hopefully that mentor is going to come in and say, you were absolutely right in that this is hinting something bad at you. And the bad part is that you've split the responsibilities too thin. We really want to bring that validation back on the order. The order can be capable of validating itself because it needs to know about all of its pieces and parts. This is what the concept of encapsulation is really all about. But sometimes those hints are not the right way, right? So the mentor's got to really walk through the reasoning process. You don't want to come in and say, yep, that's wrong, put it together, and then move on. You want to walk through that process. It needs to be a dialogue with the more junior person, because sometimes those hints are not going to be bad, right? I may have a very complex problem with some complex objects that I've got to do a lot of setup to properly test, but I want the safety net of that test around the complexity so that I know I'm getting the business logic right. As a junior dev, I don't know how to reason about that when I see that code smell. If I'm taught, oh yeah, it doesn't feel right, just glom it all together, I'm going to end up creating objects with too many responsibilities because that's what I'm trained, right? I see a problem, just glom it together. Whereas what I really need to be able to do is I need to be able to look at it and reason about it. Oh, in this case, the order validator was using so many of the properties of the order that it makes more sense to live on the order so that I don't have to share those properties and share that as part of the interface between two objects. Oh, I get it. So the next time that comes up and they feel things are a little weird and it's not a clear-cut reason, that dialogue changes, and the dialogue will be more, it doesn't feel right. The junior dev is going to come and say, this doesn't feel right because I'm using some of the properties, but not all of them. I'm calling some of the interface methods, but not all of them. It feels like a weird split. Now that junior dev and their mentor are having a much more engaged dialogue about design concepts and principles, and together they are probably improving the system for the better. I know this one was a little more ethereal and a little bit more about how to have those conversations. Does that make sense for everyone? Does that resonate with people? Either they've been on the junior side where they are the junior person and they're maybe not understanding what they're seeing, or maybe it's better, they're understanding a way to ask for help from somebody who maybe isn't as great at mentoring, or vice versa. As the mentor, you know how to explain these concepts to the junior folks a little better. I'm seeing a number of yup, so hopefully that's an answer to that question. Oops. All right. This, I believe, is my last one up. So here I have an enumeration for colors. I have a class that is a color picker. Its sole job is to take in a string that determines a shape and then give me the color of that shape. Each shape has an assigned color. If I don't recognize the shape, it's not a part of my switch statement, I'm going to return the color black just as my default. In my program down below, I define my color picker. I pick a color for square and I print that out. I pick a color for rectangle and I print that out. Where's my bug? I've got probably one bug. I do need a default case, Brad. That is exactly right. So there are really two fundamental flaws in this. Had you caught me about a year ago, I would have said there were three fundamental flaws. The first one I would have said a year ago is that you're using a switch statement instead of an if. I'm generally not a fan of switch statements because they are tricky like this. The two things that I'm missing is that a switch statement is not like an if then else. Each case statement is not an independent block. And the way we know this is that blocks in C# are denoted by curly braces, right? Not by tabbing or spacing or indentation. Because the case statements don't use curly braces, they're not independent blocks. The entire block is the switch statement. So what that means is if I pick circle, I'm going to set return color to red. I'm then going to fall through and execute the rest of the lines of code where they make sense. Now, because I don't have a default statement, I'm not going to reassign that value, but I'm going to go through and evaluate each and every one of these. So I should have a break statement when I'm done with each one of my cases. I should also have a default case to protect against this. Now, both of those reasons are why in the past I would have said, don't use a switch statement. It really doesn't do much for reasoning about the program. It's hard to get right? It is very easy to write the code that you see in front of you and to do some really bad side effecty type of things. However, for the solution to this one, I did do the switch and case statements correctly. I put my breaks in so that each case statement, when I assign the color, I break out and I fall out of the block altogether. I hit my return statement and I move on. I also created my default case. I'm returning black here as a default. I'm doubly handling the default case. I probably don't need to. And the reason I'm putting this up here is that C# as a language is starting to introduce more and more constructs that are coming from a functional programming paradigm. And one of those paradigms is what the switch statement really does and why this one's tricky and why the breaks need to be there in the default case. Like I said earlier, the switch statement is an entire block within those curly braces. I can actually use the switch to do an assignment. I could assign a variable using a switch statement because a switch statement could have a return coming out of it or be the backside, the right side of an assignment. In C#9, they are introducing records. In C#8, I believe they introduced pattern matching. I think it was 8. I know there's pattern matching in there now, and I think it was in C#8. Pattern matching with a switch statement can allow you to assign variables based on a pattern of something coming in and do some very sophisticated matching to maybe be a factoring method to assign objects coming out. It might be a way to handle exception handling, that if my result type coming out of a try-catch function is of a success type, I want to handle it one way. If it's a failure type, I want to handle it a different way, or I want to assign things different. It becomes a very powerful mechanism. So that's why I'm showing here for that bug. Here's how you fix the switch statement. If my code is truly just doing what I'm showing here, I would personally advocate for an if-then-else block. However, if I'm getting into more complex pattern matching, we need to understand the switch statement and we need to be able to do it right. This one is probably more of a 400 level type of topic. I wanted to introduce it in for the architects, the senior devs, the tech leads in the audience to be aware of what's coming down with the switch statement and to maybe think about ways to differentiate when I use the switch statement versus if-then-else blocks for doing things like this. Obviously, there are also some code smells with the way I'm approaching this. There may be better ways of doing this in an object-oriented fashion. All of those are valid. But the reason I wanted to start pointing this out is that as senior devs, as we start to lean on and take advantage of the pattern matching and the record types that are coming out where I can do some really fancy pattern matching stuff, I'm going to rely on this expression, the switch expression, a lot more to do some neat things. As I do that, I need to make sure that I'm teaching people the right way to do it and that I'm learning it the right way. All right, that is all of the bugs that I have on track. I'm going to put my contact information back up here. Hopefully that shows up for everybody. If there are any questions, Michael posted in there that he thought people pick switch statements because it's quicker. It is probably quicker. I haven't dug in on that yet. It is most likely quicker because it is an expression that can do an assignment, whereas the if-then-else's are branching logics, and the compiler has to handle the branching of the if-then-else. Personally, from a design standpoint, I would argue that the if-then-else is easier to read, and if I don't have a lot of logic, it's easier to understand and reason about. However, I'm being sold on the switch expression as I get into doing more functional programming, in understanding the functional programming side. That construct is fundamental to some of the things that you do in a functional programming paradigm. So I may be becoming a bigger fan of that, which is also why I had it introduced into here. Are there any other questions that I can answer for anybody? I keep looking to the side because that's where I've got the chat. If not, that's our time. Thank you all very much for attending. Hopefully this was informative and fun. It's a little bit more fun when we can be in person and we can really joke and laugh about it, but I really thank you guys for attending. I hope you have a great rest of this conference. See you all.